Good day, everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. I believe you're all well. Right. Today, guys, I want to take you through the Physical Science Paper 2 for Organic Chemistry. Particularly, I'll talk about the nomenclature. Right. You know very well that in Physical Science Paper 2, Organic Chemistry, it's one of the questions it's one of the chapters that has a lot of marks because usually it comes in 3 questions. There's a part for nomenclature, which is what I want to address now. There is a part for physical and chemical properties of organic compounds, and there is also a part of organic reactions. So for now, I will dwell much into the nomenclature. Then we'll also have another video for physical properties and organic reaction. Right, without wasting time, let's now start with the session. Right, don't forget to visit our YouTube channel, which is at Kangaroo Maths and Science Academy. And remember to like, subscribe, and hit the bell button for future video notification. Let's now start with the session. Right, in terms of the learning objective, at the end of this session, a learner should be able to define what is called the hydrocarbon. You need to be able to define what is hydrocarbon. You need to be able to know what is a homologous series. You must also be able to know what is a functional group and what are structural isomers. And again, you must also be able to know the 9 homologous series in terms of their functional group and also in terms of the general formula. Guys, remember in nomenclature, once you know these 9 homologous series, knowing their functional group and knowing their general formula, you will never go wrong. Right. Again, you need to be able to differentiate between organic compounds that are saturated and also that are unsaturated. And you must be able to know the 3 kinds of structural isomer we're going to talk about, which is a chain isomer, positional isomer, and functional isomer. My apology. And also give their examples. Then also you need to be able to use the IUPAC to name organic compound using the IUPAC system or the IUPAC naming, which stands for International Union of Pure Applied Chemistry. Right. Again, you need to be able to know the different types of alcohols or also halo-alkanes, where we have primary alcohols, secondary alcohols, and tertiary alcohols. Also, primary halo-alkane, secondary halo-alkane, and tertiary halo-alkane. Then again, you need to be able to familiarize yourself with the definition of empirical formula. We went through this empirical formula under quantitative aspects of chemical change. There is a video where I explained the empirical formula, how to determine the empirical formula when you are given a percentage composition. And also, how do you determine the molecular formula when we're given the molar mass of a compound and its empirical formula? So in essence, in the part of empirical formula, I can either address this using an example, but if I don't address it, kindly visit the video in my YouTube channel for the quantitative aspects of chemical change. Then you'll be able to understand how to determine the empirical formula and what is an empirical formula. I believe you guys are following. All right, without wasting time, let's now start with the first bullet point. Remember, when you are dealing with organic chemistry, one must be able to understand what you mean by a hydrocarbon. Right. In terms of the definition, a hydrocarbon is an organic compound that consists of or that contain hydrogen and carbon and carbon atom only. So organic compounds that contain or consist of hydrogen and carbon atom only are referred as the hydrocarbon. So it means those that do not contain hydrogen and carbon atom only, they are not called hydrocarbons. In other books, they call them the derivatives. You learn them when you go to university. Right, so you must be able to define what is a hydrocarbon. It's an organic compound that contains hydrogen and carbon atom only. And also you need to be able to know what is a homologous series. A homologous series is a series of organic compound, that can be described by the same general formula. Described by the same general formula. So organic compound or a series of organic compound that can be described by the same general formula. This is called the homologous series. Right. What does this mean? It means that those compounds that have the same chemical property, that have similar chemical properties, and they have the same general formula, it's regarded as homologous series. So you need to be able to know the definition of homologous series. And we have 9 homologous series in this chapter, which we are going to talk about. So a series of organic compounds that can be described by the same general formula is called the homologous series. Then again, one must be able to know what is a functional group. It's very important to know these definitions. Right, a functional group, it's a bond. Functional group is a bond or an atom or a group of atoms that determine the physical and chemical properties of that group of organic compound. So now, what do you mean by a functional group? A functional group, it's just which has to do with the physical property and the chemical. For example, if you say this is an alcohol, how do you see that this is an alcohol? So that is called a functional group. It's the one that determines the physical and the chemical property of a group of that organic compound. So it's very important for one to be able to recite this, to be able to know these definitions, particularly under nomenclature. Then the last one is the issue of the structural isomer. And it's very important to be able to define what do you mean by a structural isomer. Right. Structural isomer is an organic compound with the same molecular formula, but different structural formula. Organic compound, so this is a structural isomer. So it is an organic compound that is the same or with the same molecular formula but different structural formula. The organic compound that is the same molecular formula, but different structural formula, it's regarded as a structural isomer. And again, guys, you need to be able to differentiate between molecular formula structural formula and the other one, it's a condensed structural formula. So when we're talking about a molecular formula, in a molecular formula, the compound only represent like we only show the number of atoms in each element with no bond attached to it. So this is an example of a molecular formula. So if you say C4H10, this is a molecular formula. C4H10 is the molecular formula. This is an example because we actually represent the number of atoms in each element with no bond attached to them. We do not show any bond on the molecular formula. But in terms of a structural formula, we show the atoms and also the bond should be shown on each atom. So we show even the bonds. This is an example of a structural formula. So in a structural formula, we also show even the bond attached to each carbon atoms. So this is an example of a structural formula. So we showed the number of like the bonds and the atoms in each element. But however, in a condensed, we just say in each carbon atom, we do not show the bonds in each without having to combine it. It means this would be the first carbon has how many hydrogen atoms? 3. So it will just be CH3. Then the second one carbon is having, so it's CH2, then CH2 and CH3. So this one, it's a condensed structural formula. I believe you're following. So in terms of the condensed and structured, it means like the carbons, like in a structural formula, we show the bonds, but in a condensed structure, we do not show the bonds. But we actually represent the atoms in each carbon atom. So it means in the first carbon, we look at the hydrogen atom in each. So there are 3. In the second, there are 2, there are 2, there are 2, but the counting should be the same. I believe you guys are following. So you need to be able to differentiate between a molecular formula, a structural formula, and a condensed structural formula. So it's very, 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 very important to be able to know that. All right. Then, as I said, that structural isomer is an organic compound with the same molecular formula, but different structural formulas. We are referring to this. It has the same molecular formula, but the structure is different. The structure is actually different. So we are going to talk about 3 types of structural isomer. I believe you're following. So you need to know that in the exam, you must be able to define what is hydrocarbons, what is a homologous series, what is a functional group, and what is a structural isomer, and also be able to differentiate between molecular formula, structural formula, and condensed structural formula. Now, I want to take you through the issue of knowing the 9 homologous series in terms of their functional group and in terms of their general formula. Remember, we already explained what is a homologous series. That is a series of organic compounds that can be described by the same general formula. So I want to take you through the 9 homologous series. This one, you need to know them. You need to thoroughly know them, ladies and gentlemen. You need to know the 9 homologous series. All right, without wasting time, I've designed a table to explain these 9 homologous series one by one in terms of their functional group and in terms of their general formula. So now, it means in this section, you will be able to also know the homologous series, which are actual hydrocarbons, and the other ones which are not hydrocarbons. Because hydrocarbons, remember we said the organic compounds that consist of hydrogen and carbon atoms only. If they don't have hydrogen and carbon atoms only, they are not referred as hydrocarbons. Right, then now we will continue to the next part. Right, here what I'm gonna do is I want to write this, okay, 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8, 9. So I want to write this 9 homologous series one by one. Right, the best way to remember them, I want to use a notation, and you need to remember this, guys. In a short way, we say R, so it means I will just say AAA, R, ha, okay. A triple A's, A, ha, double A's, K, and this K is a K with the C, with the E. Just to remember these 9 homologous series. Let me repeat again. A, triple A's, A, ha, K, but the K must have the C. So this is just a way to remember these 9 homologous series in that order. A, ha, K, A, ha, K. So what does the R represent? The first A represent the alkanes. So we have the alkanes, followed by alkenes, followed by alkynes, followed by the halo-alkanes, alcohols, aldehydes, ketones, carboxylic acid, and the last one is an esters. So, right. I want you guys to listen to me very well. These first 3 homologous series I've already mentioned. The first 3 homologous series that I've already mentioned, these are hydrocarbons. These are our hydrocarbons. Means these other ones are just derivatives. Why? Because they do not contain carbon and hydrogen atom only. We'll talk about this. For example, halo-alkane is not a hydrocarbon because in it we have halogens. Right. So you need to be able to understand, actually be able to know the 9 homologous series. And these 9 homologous series, we are also going to talk about them under physical property of organic compounds. So it's very important to be able to know the homologous series. As I said, A, ha, K, A triple A's, ha with double A's, K with the C in it. So now, to remember, again, these things, again, also you need to familiarize yourself with their functional group. As I said, the functional group is an atom or a bond or a group of atoms that determine the physical and the chemical property of a group of that organic compound. So these are called functional group. What does this mean? It means when we say this is an alkane, how do we see that these are alkanes? Listen to me. Alkanes are seen by a single bond between the carbon atoms. They have single bonds between the carbon atom. I can even use one carbon instead of 2. They are seen by the single bonds between the carbon atoms. So this is the general formula, the functional group of an alkane. Then what is the functional group of an alkene? Alkenes, between the carbon atoms, there is a double bond, where this double bond atoms have been reduced from the what? From the alkanes. If you we remove 2 atoms from the hydrogen atoms from an alkane, we end up having the alkyne. So it means the general formula, the alkene, I mean to say, the general formula of an alkene is seen by the double bonds between the carbon atoms, where 2 hydrogen atoms are removed from the alkane. So this is the general formula of an alkene, I mean to say. Then the general formula of an alkyne, I'm saying the functional group of an alkyne, I apologize guys, functional group of an alkene, it's the carbon with the double bond between the carbon, and the alkyne, it's triple bonds between the carbon atoms, where 2 hydrogen atoms are removed from the alkenes. So it means you're going to remain with this. So this is the functional group of an alkyne, with triple bonds between the carbon atoms, double bonds between the carbon atoms, single bonds between the carbon atoms. Then that is an alkane. Single bond alkane, double bond alkene, triple bonds alkynes. All right, how about the halo-alkanes? The halo-alkanes are those that contain single bonds between the carbon atoms. However, one side of the carbon, there is a halogen attached. One side of a carbon, there is a halogen attached. We can also use single, like one carbon, then we put an X. So it's also fine. This is the functional group of a halo-alkane. So what does this X represent? The X represent a halogen, the halogens which are in group number 7 from the periodic table. I believe you guys are following. So this X here, the X denotes the halogens. These are the halogen which are in group number 7, fluorine, chlorine, and others. Right. Then now, I apologize. We just use. So now, in terms of that, so I said the X here represented the halogen. So this is just the carbon atom. Okay, let me just write it again so that you can clearly see it. We can also just represent it with an X without having to put another one. You can just say single bond with an X. There's no problem with that. So right, then now it means that now we know that if we have single bonds but there's a halogen, then this is regarded as a halo-alkane. Then how about the alcohols? The alcohols are those where you find that there is a hydroxyl. There is a hydroxyl, the OH. There is an hydroxyl. If they say, we write this as a structural formula, it means it will be like this. It will be like this with the O and the H. So you see that this OH here, this OH is the one that determines what you call an alcohol. So an alcohol, the functional group of an alcohol is that on the carbon atom, one side, there is this OH. And what is the name of this OH? You need to be able to know the name of this OH. This is called a hydroxyl group. It's called the hydroxyl group. It's called the hydroxyl group. So you need to be able to know this. Right. Then lastly, ladies and gentlemen, I want to show you something very important. We have an atom, actually, let's say an atom, a compound which is called the carbonyl, OH, carbonyl. This OH, let me say, this is called the carbonyl group. It's called a carbonyl group. And if it's like this, is the same as we can just write it as CO. So this is called carbonyl group. So I want to talk about this so that you can be able to understand. It's very important. In order to know the general formula, I'm saying the functional group, okay, I apologize, guys. In order to know the functional group of an aldehyde, of a ketone, of a carboxylic acid, and of an ester, there is something that you need to understand here. On the aldehyde, on the ketone, on the carboxylic acid, on an ester, this carbonyl group is present in these 4 homologous series. So it means in an aldehyde, we still have this carbonyl group is there. Also on the ketone, we still have the carbonyl group. I think this is the way you need to remember this. Carboxylic acid, there is also a carbonyl group there, but not a separate functional group. Then even in ester, we also have a carbonyl group. So you need to understand that when you are having an alcohol, I'm saying not necessarily aldehyde, ketone, carboxylic acid, and an ester. In all these 4 homologous series, this carbonyl group is also present in each of them, but not as a functional group. Now, this is what you need to differentiate between this. Even though the carbonyl group is present in the aldehyde, ketone, and carboxylic acid and ester, within the ketone, if we have, I'm saying within the aldehyde, one side of the carbonyl, it's a hydrogen atom. One side of the carbonyl, it's a hydrogen atom, whereas the other side, it's a carbon. But for now, I will not say this it's a functional group. It's not a functional group of an aldehyde. I just want to show you something. Within the aldehyde, where we have an aldehyde, one side of the carbonyl should be a hydrogen atom, the other side should be a carbon. Unless if it's methanol, we'll talk about this. But where we have an aldehyde, one side of the carbon should be hydrogen, the other side should be carbon, or even hydrogen if we are dealing with methanol. But where we have a ketone, on a ketone, both sides of the ketone, of the carbonyl, should be a carbon atom attached. So both sides, it's carbon atom attached. So which means this is the functional group of a ketone. It's a functional group of a ketone. But for an aldehyde, the functional group is this one. The functional group for an aldehyde is this one. I'll circle it so that you can be able to see. This is the functional group of an aldehyde. Not with the carbon. I'm just explaining why I would like the difference between aldehyde and ketone. Within an aldehyde, one side should be hydrogen, one side should be carbon or hydrogen. But in a ketone, one side should be, both sides should be carbon attached on the carbonyl, which means the carbonyl here, it's a functional group for a ketone. It's not a functional group for aldehyde. It's not a functional group for carboxylic acid. And it's not even the functional group for an ester. It's for a ketone. Then, how about the carboxylic acid? The carboxylic acid, one side of the carbonyl, listen to me very well, one side of the carbonyl should be a hydroxyl group. So it means one side of the carbonyl should be a hydroxyl group, which is the OH. The other side should either be carbon or hydrogen, but one side should be the hydroxyl group. The other side should either be carbon or hydrogen. Because, for example, if we attach hydrogen, it means this will become methanoic acid. But now you need to be able to know that aldehyde, ketone, and carboxylic acid and an ester, all they have this carbonyl group, not necessarily as a functional group. It becomes a functional group on a ketone. So on one side of a carboxyl, you must see hydroxyl. The other side should be either carbon or hydrogen. Then while on an ester, listen to me very well. On an ester, the oxygen, this oxygen now, it's still there, but there is a carbon attached, no longer hydrogen. I believe you are following. There is a carbon attached, no longer hydrogen. So it means that it's supposed to, remember on the carboxylic acid, on the carbonyl, we need to see the hydroxyl group. But on an ester, it's the oxygen with the carbon atom, not the hydroxyl group. So I believe you guys are following. So now, what I will actually rectify is that the functional group of an aldehyde is this, is the carbonyl with the hydrogen. And this carbonyl with the hydrogen has a name. It's called a formyl group. You need to be able to know this. It's called a formyl group. It's called a formyl group. And bear in mind, guys, this formyl group, when we write it, and I want you guys to listen to me very well, because this is our exam typical question. Remember, we said when we have this carbonyl with the H, what is this called? It's called a formyl group, because it's a functional group of what? An aldehyde. But we know that carbonyl can be written as CO. If we write this as, remember, SCOH. Guys, listen to me. Remember, I've changed this SCO. If we write this SCOH, it's no longer an aldehyde. This is an alcohol. This is an alcohol. But if we change SCHO, so that's the difference. COH is an alcohol, but CHO, this now becomes an aldehyde. I believe you are following, guys. So in the exam, they usually ask, you must be able to differentiate between the two. And then now, it means the ketone is the one that has carbonyl as the functional group, because like between the ketone, we have two carbon atoms attached. Then how about a carboxylic acid? A carboxylic acid, this compound as a functional group is called carboxyl group. It's called a carboxyl group. It's called a carboxyl group. And this carboxyl group can be written as, remember, it's carbonyl with the hydroxyl. So carbonyl with hydroxyl, this gives us carboxyl group. So it means if we do not want to write it like that, we can still write it like this and say, okay, fine. Since we know that carbonyl can be written as CO, this is the same as COOH. So once you see COOH, you know this is a carboxyl group. Carboxyl group. It's for a carboxylic acid. It's the functional group of a carboxylic acid. However, with an ester, it does not have a name. I believe you're following. So in all the time, if you want to remember about aldehyde, ketone, carboxylic acid, and ester, you do exactly as I'm telling you. So we have carboxyl acid, a carboxyl group is a functional group, like as a functional group of an alcohol. Formyl, it's for an aldehyde. Carbonyl, it's for a ketone. Carboxyl, it's for a carboxylic acid. I strongly believe you are following. Then again, you need to familiarize yourself with the general formula. You need to know the general formula of this. And this is one of the easiest. Right. The general formula of an alkane is CnH2n+2. CnH2n+2. Let me use a visible one, like, yeah, let me just use a visible, let me just use red. So the general formula of an alkane is CnH2n+2. And for an alkene, it means you have to remove two atoms from an alkane. So it means these two will no longer be there. So this becomes CnH2n. Same applies for an alkyne. We remove two atoms of hydrogen atoms from an alkene. It will be CnH2n-2. So you need to be able to know this. Then how about halo-alkane? Halo-alkane, it's usually it's much related to an alkane, just that one atom of hydrogen is being replaced by halogen. So it means the formula now it's CnH2n plus 1 with an X. Plus 1 with an X. The X represents the halogen. Then how about alcohol? Alcohol is much related to halo-alkane. It's CnH2n plus 1 with the OH. But in other book, we can still write these as, because there's a hydrogen atom there. You need to be able to, must be able to know both this general formula. If we take the hydrogen atom, we add it onto the formula there. This will also can also be written as CnH2n plus 2 then O. Because we have taken the hydrogen atom, we added it there, it's going to be this. Right, how about an aldehyde? And guys, this is very important. Aldehyde and ketones have the same general formula. Same applies with carboxylic acid and ester, they have the same general formula. That's why we're going to talk about what is called the functional isomers. Very important. What's the general formula of an aldehyde, ketone, carboxylic? Then what to do? We take the formula for an alkene. I want to show you something. Let's take the formula for an alkene. An alkene, we have this. This is the general formula for an alkene. So if we take this general formula of an alkene, we are going to write it under all these remaining homologous series. So it's CnH2n, 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 and CnH2n. The only difference is that with an aldehyde and ketone, the general formula is CnH2n with oxygen 1O, both. Then with this one, it's 2 atoms of oxygen and 2 atoms of oxygen. So it's CnH2nO, CnH2nO, CnH2nO2, CnH2nO2. This is for the carboxylic acid and ester. Then this one is for the aldehyde and ketone. Guys, these things are very important when we're dealing with organic chemistry. If you want to enjoy organic chemistry, you need to know this. 9 homologous series, their general formula, their functional group, and also the suffix and their suffix when we're actually naming, which we'll talk about this. When we're going to name, when we're naming an alkane, the suffix should end with ane, so it's ane. Then the alkene, it's in. Alkyne, it's ine. Halo-alkane is just the ane. Then alcohol, it's al. Aldehyde, it's al. Ketone, it's on or one. Then carboxylic acid is oic acid. Then ester, it's an weight. Ester, it's an weight. We'll spend more time on this ester. So make sure that you stay tuned. And whenever you do not understand, ladies and gentlemen, then you can reach out to me. So it's very important, ladies and gentlemen. You need to know the IUPAC 9 homologous series. You need to know their functional groups. You need to know their general formula. CnH2n plus 2, CnH2n, CnH2n minus 2, CnH2n plus 1 with an X, CnH2n plus 1 with the OH, which is the hydroxyl group, or CnH2n plus 2 with the O, CnH2n with O for both aldehyde and ketone, CnH2nO2 for both carboxylic acid and an ester. You need to know this, ladies and gentlemen. Right, without wasting time, let's now continue. Unfortunately, when I move to the next slide, then this will no longer show up. So just make sure that you pause the video, you do it on your own. Then yeah. Thank you very much. Let's just continue. Don't forget to like, subscribe, and share. Right. Okay. Well, let me just stop this. Okay. Sorry. Okay, now we spoke about that, then now we can move on to the next bullet point. The next bullet point, it says you must be able to differentiate between saturated and unsaturated hydrocarbon. Remember, I said we have 3 types of hydrocarbon. The first one is an alkane, the one with the general formula of CnH2n plus 2. The second one is an alkene with the general formula of CnH2n. Then we also have the alkyne, which is CnH2n minus 2. So these two, the last two, these are regarded as unsaturated hydrocarbons. So we call it an unsaturated hydrocarbon. Whereas the alkane, it is a saturated hydrocarbon. This one, it's saturated hydrocarbon. Now, why is it called a saturated hydrocarbon? It's because it contains single bonds between the carbon atoms. Since it contains single bonds or no multiple bonds between the carbon atoms, is regarded as saturated. So this ones is because they contain at least one or two double or triple bond between the carbon atoms. Or you can say it contains multiple bonds. It contains multiple bonds between the carbon atoms. Because of that, between the carbon atoms. Because of that, they are unsaturated. They are unsaturated. So it's very important, ladies and gentlemen, to know this. Very, 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 very important. Right. Again, you need to be able to know the different kinds of structural isomers. This one I want to go deep because I want everyone to actually understand this. All right. What do you mean by a structural isomer? I think I've already spoke about that. Let me just create a space here. Remember we said structural isomers are organic compounds that with the same molecular formula but different structural formula. So there are 3 kinds of structural isomers. There are 3 types of structural isomer. Namely, the first one is called a chain isomer. The second one is called the positional isomer. Then the last one is called the functional isomer. Functional isomers. Right. Let's differentiate between these 3 types of isomers. What is a chain isomer? A chain isomer, it's an organic compound with the same molecular formula, but different chain length. The molecular formula is the same, but the chain length is different. So usually here we're talking about those organic compounds that are in the same, they have the same general formula or homologous series. But now when we talk about the positional isomer, are those organic compounds that have the same molecular formula, but different positions of their functional group. So it means they have the same functional group, it's just that they are not, their position is not the same. So same molecular formula, but different positions of their functional group. So it means the functional group are the same, just that they are not at the same position. So these are called the positional isomers. Then the last one, we have a functional isomer. With a functional isomer, it's an organic compound that is the same molecular formula. Molecular formula is the same. But what? Different functional group. Their functional group are not the same. It means that they do not belong to the same homologous series. Their functional group are not the same. We call them the functional isomer. Molecular formula is the same, but different functional group. Molecular formula is the same for positional, but different position of their functional group. Whereas for chain, molecular formula is the same, but different chain length. So it means if they have the different chain length, it means we, like for those that are chain isomers, they must have the same homologous series and actually even the same functional group. I'm saying yes, functional group, yes, even the general formula should be the same. So let's now give examples, be able to differentiate between the chain isomer, the positional isomer, and the functional isomer. But I want you guys to write to note this. When we are going to talk about functional isomer, you must know in your exam, functional isomer, number one, it can be either an aldehyde or a ketone. Why? If you can look, I said aldehyde and ketone have the same general formula, CnH2n. Or it can be carboxylic acid with an ester. Usually in the exam, these are the types of the functional isomer. It's either you're comparing aldehyde and ketone or carboxylic acid and ester. These are very important, especially for functional isomer. If they say write down the functional isomer of aldehyde, it means they need a ketone. If they say write down a functional isomer of a carboxylic acid, it means they need an ester. Guys, this is very important. You need to be able to know this. We'll do an example. Okay, let's do this. Let's say, I now understand you are used to the naming and also to know that when we have 1 carbon, it's meth, 2 carbon, it's eth, 3 carbon, it's prop, 4, it's but, 5 is pent, 6, it's hex, 7, it's hept, 8, it's oct. I strongly believe you know that. Look at this. If we look at this, I just want to demonstrate something. Let's say we have a structural isomer of butane. 1, 2, 3, 4. Remember, butane is an alkane. Okay? There is a structural formula of a butane. 1, 2, 3, 4, 5, 6. Okay? Let me just complete it. Okay, if you look at these two, okay, let's just call it compound A. Now I have to draw another compound. This time around, I want to do this. 1, 2, 3, then 4. Somewhere here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is this an example? Okay, let's do this. These two are actually structural formula because we're even showing the bonds in each carbon. Right, let's now write the molecular formula. I want to have the molecular formula. Let's do this. Remember the molecular formula, we just saw the element in the atoms in each element. Okay, fine. Let's count the number of carbons which are here. So obviously will be 1, 2, 3, 4. So we have C4, H. How about the number of hydrogen atoms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. And remember, I said this is an alkane because it contains single bond. And besides, we know the general formula of an alkane, it's CN H2N plus 2. And confirm this means, since here we have 4 carbon atoms, where there is N, if you substitute this by 4, this will be C4H. 2 times 4 is 8 plus 2, it becomes 10. You see? Okay. Now, what is the general formula of this also? Let me say the molecular formula. Let's count the number of carbon. 1, 2, 3, 4. There's still 4. Hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's still 10. You see that when we look at compound A and B, both of the two compounds have the same molecular formula. The molecular formula is the same. But what is their different? They're different if you look at this. This one has a straight chain of 4 carbon, the first one. It is unbranched. There are no branches here. But if you look at this, there is one carbon which is attached on the other carbon here, which is this. So this will now regarded as a branch. This one is a branching. So because of this, the two organic compounds have the same molecular formula, but the only difference is the chain length. The chain length are not the same. Yes, they have the same molecular formula. They are from the same homologous series. They're both alkanes, but their chain length is different. And because their chain length is different, it means even their name will change. Because the name of the first one, this will be butane. The first one will be called the butane, whereas the second one will be called 2-methyl propane. So it will be called 2-methyl propane. You see that even the name has changed. So these are actually called structural, they are actually called chain isomer. They have the same molecular formula, but different structural formula. So this is what you need to understand under the chain length. Is it the chain isomer? Okay, then now let's move on to the issue of positional isomer. Remember I said under positional isomer, we are comparing compound that is the same molecular formula, but different positions of their functional group. Let's give an example. Let's say we have it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm gonna put, let's say I put the name here. Let me say the functional group of the compound here. It's just an example. I want to compare using ketones. We know that wherever we see a ketone on the carbonyl, one side should be carbon and the other side should be carbon. So if you look at this belongs to a ketone. Why? Because within the carbonyl group, there is a carbon attached. So this is a ketone. Now, what if I draw this again? 1, 2, 3, 4, 5 with 5 carbons. 1, 2, 3, 4, 5. This time around, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. This time around, I want to place my carbonyl on this carbon here. Now, when you go, we are going to talk about the IUPAC naming. Remember, it says when you are naming, you need to choose the longest chain. After choosing on the longest chain, then you identify any branch or a functional group. Then after identifying any branch or functional group, you number your carbon starting from the nearest functional group. Functional group take priority over a branch. So now, here we are going to do this. Look at this. If we want to name this organic compound, means we have to name where we'll get to the nearest functional group. Remember, the functional group of a ketone, it's this carbonyl. No. I apologize, guys, because this will have the same name. Okay, let me just change it. There's no problem. Actually, I wanted to do this, not that. Okay, let's put the carbonyl on carbon number 3. Yes. I apologize, guys. Okay, yeah. Let's our carbonyl here. Then our hydrogen will be here. Okay. Okay. Yes. First of all, let's look at their molecular formula. The molecular formula for the first one. Let's count the carbon atoms. 1, 2, 3, 4, 5. C5. Hydrogen, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C10. And O with 1 oxygen. Same applies with this. 1, 2, 3, 4, 5. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, guys, I'm facing network issues by my side. I apologize for that. Okay, as I was saying that, from the first one we had 1, 2, 3, 4, 5. On number 3 we have this. Okay. Okay, let me just write that atom. So what is the molecular? I'll just write MF. What is the molecular formula? C5H 10 then O. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how about this 1, 2, 3, 4, 5? Then we have carbonyl here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see, they both have the same molecular formula. The molecular formula is the same. Now, but when you look at this, their chain length is actually the same. But there's only one difference on this. If you look at the functional group of the first one and the functional group at this, they are not at the same position. If we were to name this, you have to number the carbon starting from the nearest. So this will be, if we say 1, 2, 3, 4, 5. If you come to this will be 1, 2, 3, 4, 5. So you see that the functional group on the first, it is at position number 3. And this one is at position number 2. Yet they have the same functional group. Their functional group are the same. So what does this mean? This is an example of a positional isomer. Why? They have the same molecular formula, but different positions of their functional group. They have the same functional group also, but their positions are different. One is at position 3, One is at position 2. That's why in terms of this, the name will change because we have 1, 2, 3, 4, 5. This will be pentanone. Actually, it will be pentane 5-on. Or I'm saying pentane 3-on. I apologize. Then this one will be pentane 2-on. You see that the name has changed. This is at position 3. This is at position 2. 1, 2, 3, 4, 5. 5 means pent. So it's pentane 2-on, pentane 3-on. So these are examples of positional isomer. But when you talk about functional isomer, remember I said number 1, you need to compare ketone and aldehyde. For example, let's do this. Let's say now I have this. Okay, let's say I want to remain with pentane 2-on. And I want to change this pentane 2-on to now, remember it's a ketone. I want to change the ketone to be now an aldehyde. I'm changing a ketone to be an aldehyde now. What's going to happen? Remember we said the functional group of a ketone. Ketone, how do you see that is a ketone? Carbonyl group with carbon attached. Then now about aldehyde, carbonyl group, one side should be hydrogen. So it means where there is a carbonyl, one side should be hydrogen. So it means to change this, we have to move this. It should be at the end actually where we can have hydrogen. So you see that we say 1, 2, 3, 4, 5. And we put the carbonyl here with the hydrogen. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If you look at these two, they still have the same molecular formula. But there's something that has changed. Their functional group is no longer the same. This one belongs to a ketone. This now belongs to an aldehyde. But they have the same molecular formula. It's C5H10O, both of them. I believe you're following. So you see now that these are now regarded as functional isomers. Same molecular formula, but different functional groups. So we compared ketone and aldehyde. I believe you're following. And the other one is the carboxylic acid and the ester, which we'll talk about that later. I believe you are following. So you need, in the exam, you must be able to know the difference between chain isomer, positional isomer, and functional isomer. Very important. Very, 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 very important. Okay. Let's now check what is it that we need to cover now. The issue of the esters and carboxylic acid in terms of their functional isomer, we'll talk about that. There's something that I want to address first. Okay, let's move on. Let's move on to, okay. So we have addressed the issue of, like we went through up until the issue of structural isomers. So we've covered this. Now, what is it that we need to look at now? So 1, 2, 3, 4, we've covered. Now we have to look on the issue of naming of organic compound. But before we do the naming, guys, let's talk about the issue of alcohol and halo-alkane in terms of primary, secondary, and tertiary. All right, let's start with the alcohols first. By the way, guys, what is the functional group of an alcohol? How do we see that we have an alcohol? Functional group of an alcohol, it's the carbon attached to OH. And what is the OH? Hydroxyl, which is the same as COH. Now look at this. Look at this. Consider an alcohol. Let's say I have 1, 2, 3. Okay, guys, as I was still saying that we're busy with alcohols, I said consider an alcohol. Let's say we have the following type of an alcohol. Let's say we have 1, 2, 3, 4. Then here we have an alcohol. I'll just write an alcohol. It's a functional group. Okay, then we have 1, 2, 3, 4, 5, 6, 7, 8. Remember, general formula of an alcohol, it's CN H2N plus 1 with the OH. Let's confirm that. Carbon, how many carbon are you? 1, 2, 3, 4. If you put 4, this would be C4H. 4 times 2, it's 8, plus 1, it's 9 OH. It means we must have 10 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, fine. So now, if you look at this alcohol here, if I change this alcohol, let's say I draw another one. Let's say we have 1, 1, 2, 3, 4. Okay, 1, 2, 3. Then let's say here it's OH. Then we have the 1, 2, 3, 4, 5, 6. Okay, with 4 components, 7, 8, 9. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me draw another one. Let me draw another one. 1, 2, and 3, and 4. Just want to explain something here. Okay, then with the OH. Right, I want to use a different color. Okay, let's see, this is the first one. Okay, the second one. And yeah, let me just use a different color. Okay, first of all, let's look at this compound here. All of these compound, all of them, they're alcohols because their functional group is just hydroxyl. They're all alcohols. It's an alcohol, it's also an alcohol, and this is an alcohol. So if we look at this is a hydroxyl group. Same applies with this is also an hydroxyl group. Also, even this one is also a hydroxyl group. All right, but now look at this. If you look at the carbon, let's now consider the carbon that is attached to hydroxyl group. The carbon that is attached to hydroxyl group, the carbon attached to hydroxyl group is this one, this. Now, since this is the carbon that is attached to hydroxyl group, how many other carbons are bonded to this carbon which is attached to hydroxyl group? If you look on the first one, let's call it number 'A', number 'B', and number 'C'. The carbon attached to hydroxyl group, the carbon that is attached to hydroxyl group, it's only bonded to one carbon atom, this one. Because this is just hydrogen, this one is hydrogen. But when we come to this, let's go and identify the carbon that is attached to hydroxyl group. The carbon that is attached to hydroxyl group is this one. And now, within that carbon which is attached to hydroxyl group, how many other carbons that are bonded to this one? So when we count there, we only have two. It's only this carbon and that one which are attached to this one. So two carbons are bonded to this carbon atom which is attached to hydroxyl group. But when we look at the third one, let's identify the carbon that is attached to hydroxyl group. The carbon that is attached to hydroxyl group is this one. So now my question is, how many carbons which are bonded to this carbon which is attached to hydroxyl group? Let's count them. So is this one, and is that. So you see that within these three alcohols, the first one, the carbon atom which is attached to hydroxyl group, it's bonded to one carbon atom only. But to the C atom or the carbon atom that is attached to hydroxyl, it's bonded to two carbons. But this one is bonded to three carbons. Which means an alcohol whereby the carbon atom attached to hydroxyl group, it's bonded to one carbon atom. This is regarded as a primary alcohol. This is a primary alcohol. So this one, when the carbon atom attached to hydroxyl group is bonded to two carbon atoms, this is regarded as secondary alcohol. Then this will be a tertiary alcohol. So what is a primary alcohol? A primary alcohol is an alcohol in which the C atom or the carbon atom attached to OH, which you call it the hydroxyl group, is bonded to one C atom or one carbon atom. If the carbon atom attached to hydroxyl group, OH, is bonded to one, then it's regarded as a primary. But if the C atom or the carbon atom attached to hydroxyl group, the OH, is bonded to two carbon atoms, then this is regarded as a secondary. But if it's bonded to three atoms, then three carbon atoms, then it's regarded as a tertiary. Same applies with the halo-alkane, but in the case of alkane, we're not going to talk about the hydroxyl, we're going to talk about the halogen. Okay, I was still talking about the primary and secondary halo-alkanes together with tertiary. I apologize, guys. I'm just experiencing connection issues. All right. As I was saying, that the same definitions, now we change it for an halo-alkane. We're not going to talk about the hydroxyl group. Now we're going to talk about the halogen. So the C atom or the C carbon, the carbon atom attached to hydrogen group, it's bonded to, when it's bonded to one carbon atom, it's going to be a primary halo-alkane. Two carbon atoms, it's secondary, and three carbon atom, it's tertiary. Then before we talk about the IUPAC naming, guys, I want us to remind ourselves with the empirical formula. Remember, the empirical formula is the simplest whole number ratio. Simplest whole number ratio of atoms. Ratio of atoms in a compound. For example, if we have butane, the molecular formula of butane is C4H10. If the molecular formula of butane is C4H10, what will be its empirical formula? So it means the empirical formula, it is the whole number ratio. Whole number, it means we have to simplify these ratios to its simplest form. So it means you're going to look for a number that goes into 2 and into 10 to its simplest. So it's going to be C2H5. So we divided everything by 2. So it means this is the empirical formula of butane. Sometimes in the exam, they'll say, write down the empirical formula of butane or something. So you must be able, don't write the molecular, you have to write as a simplest whole number ratio of atoms in a compound. Then again, you must be able to calculate the empirical formula when we are given percentage composition. Guys, this I've already created a video for the empirical formula under stoichiometric calculations. Kindly go through that and understand how to calculate the empirical formula. Right. Again, I think we're gonna go straight to the IUPAC system or the IUPAC naming of organic compound. Right. In terms of naming of organic compound, guys, I strongly believe that all of you already know that when we have one carbon, this is called meth. Two carbons, it's eth. I understand, like I strongly believe you understand that. And even the issue of alkyl groups. The issue of alkyl groups, I strongly believe you understand that. All right. Without wasting time, let's now go through the IUPAC naming. Now, let me just explain what are the steps of naming organic compounds. Then from there, I will also demonstrate some of the by using examples. Number one, in terms of the IUPAC naming, the IUPAC naming of organic compounds. Okay. Number one. Okay. In terms of the IUPAC naming, as I was saying, I apologize, guys. I have connection issues. IUPAC naming of organic compounds. Number one, when you are naming organic compounds, number one, let me just use a different. Always you need to choose the longest chain. You have to choose the longest carbon chain. And these longest carbon chain, usually it must include the functional group. With the functional group. So it means the functional group should be part of that longest chain. Now, number 2, after choosing the longest chain, then you identify any branch. Actually, let me just talk about this first. You identify the functional group, but I strongly believe that functional group will already be included, and the branch. So you need to identify any functional group and the branch. I'll tell you why I'm talking about functional group first. When we are naming organic compound, functional group take priority over a branch. So you first consider a functional group, then followed by a branch. And when we talk about branches, we are referring to alkyl groups or alkyl substituent, and together with the halogens. And guys, when we talk about alkyl group, we are just talking about a group where one hydrogen, it's a group resulted when we remove one hydrogen from the alkanes. So if we just talk about alkanes, for example, if you talk about methane, or we talk about ethane, or we talk about propane. What is functional group of, what is the molecular formula of methane? Methane, it's CH4. So ethane, it's C2H6. Propane, it's C3H8, according to the general formula of CN, H2N plus 2. So if you put 1 here, this will be 4. If you put 2 times 2 is 4 plus 2 is 6. If you put 3, then it would be 8. So if we remove one hydrogen, from methane, and this will become an alkyl group. So I'm saying one hydrogen from alkanes, I'm to say, not necessarily methane. So if we remove one hydrogen from an alkane, this will become an alkyl group. So in a way, an alkyl group, it means if you remove one hydrogen from methane, this will give us CH3. One hydrogen from ethane, it will be CH3 and CH2. Actually, let me just say CH2 and CH3 to indicate that a hydrogen is being removed. So it will just be CH2 and CH3. There was supposed to be 2 carbons and 6 hydrogens. So this one will be CH2, and CH3. These are called the alkyl group. And the one which we have CH3, this is called methyl or methyl group. It's a methyl. Then the CH2 with CH3, this is ethyl. Then the CH2 and CH2 and CH3 is called propyl. In other book, they call it an N-propyl. But in your syllabus, usually they talk about this too. Even the propyl is also part of. So when you are naming organic compound, ladies and gentlemen, number 1, you need to choose the longest chain. You choose the longest chain, and this longest chain must include the functional group. Then secondly, you identify any functional group and branch. And when we talk about branch, you're talking about alkyl group and halogen. Then number three, you must number the carbon atoms. Number the carbon atoms starting from the nearest. Functional group. I'm starting with functional group. Where we can get a functional group faster. Means functional group has priority over branch. Functional group or branch. So I'm starting with the functional group. Functional group and branch. So it means functional group takes priority. followed by a branch. So first of all, you choose the longest chain, longest carbon chain, which also must include the functional group, that longest chain. After then, you identify any functional group and a branch, but please look at the functional group and a branch, but already functional group will be included initially there. Then you number the carbon atoms starting from the nearest functional group or branch. So which means functional group takes priority over branch. So these are the steps that you need to follow when you are naming organic compound. But now there are still other things that you need to also consider, but these are the key. Number one, you choose the longest carbon chain. That will include the functional group. Secondly, you identify if there is any, you identify functional group already will be included there, and a branch. When you talk about branch, you're talking about alkyl groups, which is methyl, ethyl, or propyl, together with halogen, fluorine, chlorine, and bromine, and iodine. So now, there are other things that I need to talk about when we're actually considering alkyl groups and halo-alkane, especially when, let me say, halogen, especially when we are dealing with halo-alkanes. But there are some cases where you find that, okay, we'll talk about this. We'll talk about this. Let me not confuse you. Right, like I don't want to erase this. I want to talk about something first before we erase that. Okay, if you can look here, it says write down the name of the IUPAC when given the structural formula or a condensed structure formula for compound from homologous series, but restricted to one functional group per compound. Okay, except for halo-alkane. For halo-alkane, yes, you can have multiple functional group. For halo-alkane, maximum of 2 functional group per molecule. Maybe you can have bromine and chlorine. Right, then now another thing is the issue of we need to write down the structural formula when we're given an IUPAC name for the above homologous series, which we'll talk about that. And there's something we need to identify. Identify alkyl substituent, which I was talking about, alkyl groups. So you must be able to identify alkyl substituent or alkyl groups such as the methyl and ethyl in a chain to a maximum of 3 substituents on a parent chain. So it means when you talk about parent chain, we're talking about the chain that is the longest, like the longest carbon chain is the one with the parent chain. So now, so it means in your syllabus, when they say to a maximum of 3 alkyl substituents, they're referring to methyl, ethyl, and propyl, or N-propyl. But usually they use methyl and ethyl, but you must also learn how to use the propyl. Right, then now, thirdly, yeah, like on the fourth part, there's something that I want to emphasize here. When you are naming this organic compound, this is something very important here. It says when naming halo-alkane, when you are dealing with halo-alkane, and this is very important, guys. When you are naming halo-alkanes, the halogen atom do not get preference over alkyl group, particularly when you are dealing with halo-alkanes. So when you are naming halo-alkanes, guys, you must know that you do not give halogens preference over alkyl group. So it means you give alkyl group. Okay, as I was saying that when you are dealing with halo-alkanes, when you are naming halo-alkanes, ladies and gentlemen, the halogens group, so we're referring to the halogen atoms actually. What are they? Fluorine, chlorine, bromine, and iodine. They do not get preference over alkyl group. So you give preference on alkyl groups. So the methyl, the ethyl, and the propyl. So when you are naming halo-alkanes, halogens atom do not get preference over alkyl groups. So usually you have to, numbering should start from the end nearest of the first substituent, either the alkyl group or the halogens. But now, in halo-alkanes, where bromine and chlorine have the same number when numbering from different ends of chain, you always give preference by considering the alphabetical order. If they are the same, like they're at the same position, moving from left to right, so you give preference, like you consider the alphabetical order. When an alkyl group is a substituent in a molecule, it should be treated as a substituent. So, which means that when you are dealing with halo-alkanes, you do not, halogens atom do not get preference over alkyl group. But if they are both at the same position, so what is it that you should give preference? The alkyl group. But if you have bromine and chlorine, which are like they're at the same position from left to right, then here you consider the order. And when you're writing the IUPAC names of the substituent appear as prefix written alphabetically, bromo, chloro. So it means when you are naming, you need to name them alphabetical. And if there are two, you must use di. If there are three, you must use try. So now let's go through the questions. Remember, number one, what did I say? You number the carbon atoms, and you choose the longest chain with the one with the functional group, which is called the parent chain. Then you identify any branch or functional group. Identify branches or a functional group. When I talk about branch, I'm talking about halogen or alkyl. Then you number the carbon atoms starting from the nearest functional group and followed by branch. So you give priority over what? You give priority to a functional group followed by branch. But if you're dealing with halo-alkanes, halogens atom do not get preference over alkyl groups. Numbering should start from the nearest, start from the end nearest to the first substituent, either alkyl group or halo-alkane. I'm saying halogen. So this condition is for halo-alkanes. So let's now go through the examples. Okay, now I will first start with the, let's call this activity number 1. Okay, yeah, that's activity number 1. I strongly believe you are following. Okay, number 1, it says, okay, according to this question, it says 4 options are provided as possible answers to the following questions. Each question has only one correct answer. Choose the answer and write only then the letter A to D next to the question. So we start with 2.1. 2.1, it says, which formula shown below represent a molecule of an ester? First of all, if you want to understand, you must know the general formula of an ester. It's CnH2nO2. And even its functional group. We know with an ester, we have a carbonyl with an oxygen and a carbon. So this is a functional group of an ester. But when you look at this is not an ester, it's an alcohol. This one, what is this? It's a carboxylic acid. This one, between the carbonyl, both sides are carbon. So this one is a ketone. So obvious, this is the answer. So this is an ester. So the answer is number D. So you need to know the functional groups of organic compounds. While waiting, okay, we can now move to 2.2. 2.2, it says which one of the following cannot be an ester or carboxylic acid. Right, what are the general formula of an ester? It's CnH2nO2. Looking at this, with with 3 carbon, if you put 3 here, this is supposed to be 6, but now the problem is O, it's not O2. So this one is for either a ketone or a carboxylic, an aldehyde. Now, if we look at this, C3H4O2, C3H4O2, what is this? Where there is N, if we put 3 here, so this will be C3, it's supposed to be 3 times 2, which is 6O2. And yet even this one cannot be. Now, if you look at this has 1 carbon, 2 hydrogen, O2. So if you put 1 here, so this will be C1, H2 times 1 is 2 with O2. So this can be. Even this can be because it's 2 times 2, it can be. But now we have two, like we have 2 of this. Unless if we are considering this as an empirical formula, because they do not talk about as an empirical formula, but it will be an empirical formula for what? If you multiply by 2, it will be C6H12O2, which if we divide by 2, this will be an empirical formula of either an ester or a carb, but they did not mention because they said which of the following cannot be an ester. So it means this can be an ester, but as an empirical formula. And not necessarily, I think the answer is this. The answer is B. Cannot be. The answer is B. I believe you are following. Okay. Right. Now, let's now move on. So the first answer is D. The second answer is B. Okay. Remember, practice makes perfect. Okay, let's now move to 2.3. 2.3, what do you have? It says consider the organic compound represented below. First of all, let's first check to which homologous series does this compound belongs to. You see, this compound is a double bond, so it is an alkene. It belongs to an alkene. And what is the general formula of an alkene? CnH2n. Right. According to the question, it says consider the organic compound represented below. The compound is saturated. No, the compound is unsaturated. Already, this is out. The compound is unsaturated. The compound is unsaturated because it contains multiple bonds between them. So it means the part of saturated is already out. Now it means you have to choose between B and D. But if we look at this, if we choose the longest chain, what are we going to have? It will be the one with which you have to include the functional group. So you're going to have 1, 2, 3, 4, 1, 2, 3, 4. So 1, 2, 3, 4 as the longest, 1, 2, 3, 4. You see that if we choose the longest chain, it will have a branch. So this will be an unsaturated and also branched. So it's a branched organic compound. Even its name will actually change. It's a branched organic compound. Because if we choose the longest chain here, it will, like the longest chain will have how many carbon as the parent? It will be 1, 2, 3, 4, 1, 2, 3, 4. You see, it's either we choose this, so it will have a branch. So it's unsaturated and it's also branched. It's a branched organic compound. All right. Now we move on to the next question. The next question says that Okay. Then now, 2.4, it says a structural isomer. Okay, a structural isomer of butane it's which one here is the structural isomer of butane? Remember, structural isomer, it means they must have the same molecular formula, but different structural formula. But now, what is the structural formula of butane here? If you look at this, first of all, butane has a molecular formula of C4H10. And already propane has 3 carbons, so it cannot be. Then 2-methylpropane. 2-methylpropane. Remember, a methyl, it's an alkyl group with 1 carbon. Propane has 3 carbons. So 3 plus 1, this will give us 4 carbons. So it will have 4 carbons. This one is 2-methyl-bute, so it's 5 carbon already. 2.2 dimethyl, so we have 2 alkyl groups plus propane, which is 3 plus 2, which is 5 carbon. So already the correct answer is B. The correct answer is B. The structural isomer of butane is 2-methyl. No. The answer is it's C. Sorry, I apologize. 2-methyl propane, not B. 2-methylpropane is the answer for, yeah, the answer is C. Then 2.5, it says alcohol forms a homologous series. This means that alcohol have similar chemical property, similar physical property, it's the same molecular formula, not the same molecular formula. Not all alcohol have the same molecular formula, and not all have the same, physical, they have the same chemical property. The answer is number A. Have similar, not necessarily same, I apologize, have similar chemical property. So the answer is number A. Right, 2.6. 2.6, it says, which one of the following general formula represent alkyne? Already number A, it's not the answer. CnH2n plus 2, it's an alkane. CnH2n, yeah, this is an alkyne. This is an alkene. And this one, it's not a general formula of any, it's none. So it means the correct answer is B. This one, an alkyne. Okay, right. I apologize, guys. I'm having connection issues. I don't know what is the matter. Okay, yeah. Let's continue. Okay, we're still busy with 2.6. Now I'm gonna move on to 2.7. Right, 2.7. It says, which one of the following homologous series does not contain carbonyl group? Carbonyl group does not contain carbon, not as a function, but does not contain carbon. Obvious, the answer is an alcohol. Because aldehyde has a carbonyl group, carboxylic acid has a carbonyl group, even an ester has a carbonyl group. So the answer is an alcohol, it's B. Which one of the following, 2.8, of the following compound cannot be an alkene? Remember, with an alkene, what is the general formula of an alkene? CnH2n. So if it's 1 carbon, this should be 2. Let's check. 2 times 2, this can be an alkene. 3 times 2, this can be alkene. 4 times 2, this can be an alkene. How about this? 3 times 2 is supposed to be 8. This is an alkane because it's CnH2n plus 2. If we put 3 here, 3 times 2 is 6, plus 2 is 8. So this is propane. And what is the question? It says, which of the following cannot? So it means the answer is C. So you need to be able to know the general formulas, ladies and gentlemen. All right, 2.9. Let's move on to 2.9. 2.9, what are we given? We're actually given alcohols. And how do we see these alcohols? By its functional group, the hydroxyl group. And what is the general formula of an alcohol? CN H2N plus 1, then O. Okay, or OH, I mean to say. So it's CN H2N plus 1 with the OH, or the other way around. CN H2N plus 2 with the O. Okay, first of all, let's look at this. This is an alcohol with the OH. And what kind of an alcohol is this? Let's look at the carbon that is bonded to hydroxyl. It's attached to it, so it's bonded to amine carbon 1, 2. So it means this is a secondary alcohol. Let's come to this. The carbon that is bonded to OH, attached to OH, is bonded to 2, which is that and that. It's also a secondary. Let's come to this. This one, it's also a secondary because it's bonded to 2. Let's look at this one. This, the carbon attached to OH is bonded to only 1. So this is a primary alcohol. Okay, according to this question, it says, which of the above have the same IUPAC name? So when you are naming, which one have the same IUPAC name? Let's start with the first one. It's an alcohol, guys. How do we name organic compound? IUPAC naming. Number 1, we choose the longest chain, but must have the functional group inside, or the parent chain. Which one? Let's check. 1, 2, 3, 4. 1, 2, 3, 4. So the parent chain here, it's 4 carbon. The longest chain has 4 carbons, if I'm not mistaken. So it's 1, 2, 3, 4. 1, 2, 3, 4. Right. Remember, it's part of the functional group. Now, secondly, we identify a branch and a functional group. Okay, fine. Already we have a functional group. And we already have a branch. There's a branch. And what is this branch called? Methyl. Call it a methyl. Right. According to the numbering, which one comes first between when do we give priority between methyl and functional group? We give functional group priority over the alkyl group or a branch. So which means you can say 1, 2, 3. So we must start on the left so that we can remember it said choose the longest chain, identify any functional group and a branch, then number your carbon atoms starting from the nearest a functional group or a branch. So you're going to have 1, 2, 3, and 4. We are numbering where we can reach to the nearest functional group. Because if we move from this side, 1, 2, we'll reach to the nearest alkyl group. So first we give priority on the functional group than the branch. So the parent chain has 4 carbons. So it means this will be, what is our branch? The branch, it's methyl and it is at carbon number 3. So it will be 3-methyl, 4 carbon is but. So this will be butane. And where is our functional group at carbon number? So it will be butane to all. So it's 3-methyl butane to all. We give priority on the functional group than branch. I believe you're free. 1, 2, 3, 1, 2, 3. Because if you start this side and say 1, 2, 3, we'll get a branch, a functional group at carbon number 3. And the branch will get 2, which is wrong. So it's 3-methyl butane to all. Let's come to this one. This one, what is our longest chain? Our longest chain is 1, 2, 3, 4, 5. So it's all of this. Already, this is our functional group. We do not have a branch. And how do you number this? We need to number where we can number the carbon starting from the nearest functional group or branch. So it means we can say 1, 2, 3 from left, 1, 2, 3. So it's the same whether we're moving from left or from right is the same. 1, 2, 3, 1, 2, 3. So what is the name? What is the parent chain? Parent chain has 5 carbons. So this will be pen 10, 3 all. Pen 10, 3 all. Yes. 1, 2, 3, 4, 5. Yes, pen 10. You see already 1 and 2, they're out. The one which will have the same IUPAC name. Let's look at number 3. Number 3, let's choose the longest chain. 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. So the longest chain is the one with 4 carbons. 1, 2, 3, 4. 1, 2, 3, 4. And like, let's now identify any branch. There is a branch and a functional group. Functional group is there, and there's also a branch. Right. How do we number? We number the carbon atoms starting from the nearest functional group, which means we need to start from left to right. 1, 2, 3, 1, 2. So it means it's going to be 1, 2, 3, 4. We give priority on functional group than branch first. All right. Usually, unless if we are dealing with alkanes. So what would be the name for this? This will be, where is our branch? Our branch, it is at carbon number 3. So this will be 3-methyl. 3-methyl. How many carbons are here? 4. It will be butane with what? 2 all. So you see that the what we got here and what we got. So the answer is 1 and 3. 1 and 3 only. It's 1 and 3. Because let's check the last one. Choose the longest chain. What are we going to have? Remember, it must include the functional group. So you want 1, 2, 3, 4. 1, 2, 3, 4. So it means you have to include this. It must include the functional group. The functional group should be part of the chain. Now, here it's our functional group. Here it's our branch. Our branch is methyl. We give priority over functional group than a branch. So which means our numbering should be from here 1, 2, 3, and 4. And what will be the name? The name here, the branch is at carbon number 3. So this will be 2-methyl. 2-methyl, because the branch is at carbon number 2. With 4 carbons, this will be butane 1 all. Sorry, butane 1 all, which is the same as butanol. So it's 3-methyl butanol, this one, because the functional group is exactly at carbon number 1. So you see that this and this one are not like, so it's the answer is 1 and 3. I believe you guys are following. Okay, now let's move on. Let's move on. Functional group and a branch, we give priority on the functional group than a branch all the time. Okay, right. So we've seen that the answer is 1 and 3 only. Right, now let's move on to 2.10. 2.10, what are we given here? The question says, which one of the following represent a ketone? Already we have the answer. That's why you need to be able to know the functional groups of organic compound. For example, this one, the first one is a ketone because between the carbonyl, we have carbon attached. So it's a ketone. This one, within the carbonyl, there is an oxygen with a carbon. So this is an ester. This one, within the carbonyl, there is a hydroxyl group. So this is a carboxylic acid. Then this one, it's an alcohol. So a ketone, it's number A. I believe you guys are following. Okay. Right. Now we move on to 2.11. 2.11, it says, okay, there's something that I did not address, but it's fine. It says, consider the compound with molecular formula of C4H10. C4H10, this is a butane. It's a molecular formula of butane. How many structural isomer does this compound have? Obvious, for a butane, if you want to draw the structural isomer for butane, it will just be butane with 4 carbons. And the other one will be, it means if you want to draw the another, it means you have to move 1 carbon and attach to the other one. So you only have this only. There's no way you move this carbon anymore. So you'll have only 2 isomer. So it means butane has 2 isomer. It's only the butane and the 2 methyl propane. So the answer is 2. I believe you are following. Okay, 2.12. Which of the following is an alkane? What's the general formula of an alkane? CnH2n plus 2. Let's check this. This cannot be an alkane. Because if it's 8 times 2, this is an alkene. So already it's out. How about this? If you put 6 where there is n, 6 times 2, it's 12. 12 plus 2 becomes 14. So this is the answer. Because if you look at the 7, if you put 7 where there is n, 7, 2 times 7 is 14. And 14 plus 2, it's 16. It's not. 7 also, it's not. So it means the answer is B. Okay. Then which of one of the following organic compound represented by the molecular formula? C5H10. C5H10, this can be a molecular formula for an ester or a carboxylic acid. Why? Because it's CnH2nO2. But when we look at this, it says it's ethyl ethanoate, ethyl propanoate, butyl ethanoate, propyl ethanoate. You see, they all have weight. So it means these are esters. So these are esters. So we want to check which one is the molecular formula for one of these esters. Straightforward. Let's write down the molecular formula of each. Then we'll be able to tell. Eth, it's how many carbons? 2. Eth also is 2. So already ethyl and eth, it will have 4 carbons. So already it's out because here we're talking about 5. Butyl, but means 4, eth means 2. So 4 plus 2 is 6. It's already out. Ethyl, 2 carbon, prop, 3. So already it's 5. Propyl, it's 3. Butyl, it's 4. There are 7 carbons. So the answer is C. And actually, I did not talk more about an ester. Guys, you need to understand that when we are dealing with an ester, let me just talk about an ester because of this example. So the answer is C. An ester is actually formed by 2 organic compounds, which is an alcohol. If we take an alcohol, we combine this with a carboxylic acid through a catalyst called sulfuric acid, which is a dehydrating agent. It's acts as a catalyst, then it will give us an ester plus water. So what does this mean? It means that when we are given an ester, okay, I apologize, guys. When we're given, if you want to know what is the name of an alcohol or an ester, usually when we are naming an ester, remember I said the ester, the naming of an ester takes the weight, the suffix it end with weight. So the name of an alcohol, the alcohol becomes like the alcohol becomes an alkyl group, and the carboxylic acid becomes the weight, the weight part, which means when we have ethyl ethanoate here, it shows that they've taken ethanol. Because of this, they combine with ethanoic acid. Then to form ethyl ethanoate. For example, here, if we have ethanol, it means ethyl, it means they've taken ethanol as an alcohol. Then they combine with propanoic acid. So it means the weight comes from a carboxylic acid. For example, propyl, it means they've used propanol as an alcohol. It combined with butanoic acid. Butyl ethanoate, so it's a butanol and ethanoic acid. So we'll talk about this. We'll talk about this. So, but the answer here, it's number C. The answer here is C. Ethyl propanoate, because ethyl has 3 carbons, prop it's 2. I'm saying ethyl is 2 carbons, prop is 3. So 2 plus 3 gives us 5 carbons. So already it means it is the one which will satisfy that molecular formula. I believe you guys are following. Remember, practice makes perfect. Okay. Let's now move on to the next question. Right, 2.14, it says, which one of the following compound has a structural isomer? Which one of the following compound has a structural isomer? If you look at the number A, this is a halo-alkane with chlorine as a halogen. So if we move this chlorine even to this side, the name will be the same. So it will not have any, it will not have a structural isomer. This one. Let's look at this. With the second one, bromine. This is the naming, it's bromo, or we can say one bromoethane. This is one chloroethane. Even if we move it to the next, it will still give us the same. So it will not have any structural isomer. But let's look at this one. This one, guys, still it will not change, because if we move this chlorine this side, the naming will still be the same. Because this will just be 1, 2, which will just be 1.1.2, then tetra. Is it tetra? Yes, tetra, 1, 2, 3, 4, 5, pent. So now you see, like, this will not even have any structure. But let's look at number D. The D is the answer. Why? Because with the D is the answer. If you look at this now, it's already, if we choose the longest chain, it will be 1, 2, and with bromine, see, this will be 1.2 dibromoethane. But now, if we change this bromine, we place it here. So it's going to be 1, 2. We can put the bromine, both of them, here. So it will now have a structural isomer, because the name will now become 1.2, 1.1, so 1.1 dibromo. What? Ethane. You see, it has the same molecular formula, but different structural formula. So this one is the correct answer. Okay? Remember, practice makes perfect. Okay, let's move on to 2.15. 2.15, what do we have? Okay, let's first analyze our organic compound. Consider the organic compound from 1 to 4. This one, the first one, it belongs to an alkyne, triple bond. Even this one is an alkyne, triple bond. This one is also an alkyne. They're all alkynes. Okay, so they're all alkynes with the general formula of CnH2n minus 2. So let's look at the question. The question says what? Okay, guys, let's continue. I apologize. Today I'm having connection issues. Okay, here it says which of the organic compound or the compound above are structural isomers. I think we can easily see that without having to give the naming. Let's do this. Let's now count the number of carbons in each so that we can be able to identify the molecular formula of each organic compound. Okay, let's start with this one. How many carbons are here? 1, 2, 3, 4. So this C4H, 1, 2, 3. Okay, so how many hydrogen? 3, 4, 5, 6. So this is 6, 4 times 2 is 8. Okay, fine. Let's come to this 1, 2, 3, 4, 5. This is 5 carbons. With how many hydrogen? 6, 7, 8. 5 times 2 is 10. Okay. Then this one, how many carbon? 1, 2, 3, 4. C4 hydrogen, it's 6. Let's come to this 1, 2, 3. So it's 3 hydrogen, it's 4. Okay. Then now, looking at this, you see that since these two are not having the same molecular formula, so they are out, these two. So it means these two are the one. And I believe in terms of their naming, this will be 1. Okay, this will be, if you choose the longest chain, this will be the longest chain with the functional group, which is functional group is at the carbon number 1. It's between like a carbon 1. So it's 1, 2, 3, 4. This will be what? This will be butane or but1-ine. So this will be but1-ine or butane. Actually, let's just call it butane. So this will be butane. And how about this? Choosing the longest chain branches here. Okay, now let's number. Okay. Right. As I was saying, that the answer here would be 1 and 3, because their naming will actually change. Because the first one, as I said, this will be butane or but1-ine. Then this one will be 1, 2, 3, 4. So the double bond is between 2 and 3. So we take the smallest number, which is 2. So this will be but2-ine. But2-ine. Actually, these are actually positional isomers. Same molecular formula, but different position of their functional group. So the answer is 1 and 3. Apologize. Okay. Then now, let's move on. Moving on. Okay. 2.16. 2.16, it says, which one of the compound is an unsaturated? Unsaturated, we know unsaturated means that those that contain multiple bonds. Hydrocarbon. This, it's an aldehyde, ladies and gentlemen. Because the carbon is attached to H. So since it's an aldehyde, this is not a hydrocarbon. So it's not the answer. It's not a hydrocarbon. This, it's a hydrocarbon. It's an alkene. And it's unsaturated. This is the correct answer. This one, it's an alkane. And it's saturated. This one, it's a carboxylic acid. It is it's not a hydrocarbon. So the answer is B. It's not a hydrocarbon. So the answer is B. I believe you guys are following. Okay? So number B is the answer. Practice makes perfect. Let's move on. 2.17, okay? 2.17, it says, which one of the following compound is saturated? Saturated. Not necessarily saturated hydrocarbon, but it is saturated. We're not talking about the hydrocarbon. We want the one which is saturated. Remember, there's a difference between saturated compound and saturated hydrocarbon. Now, if you look at this, what is this? Let's look at what is this general formula for? This is butane. Butane, it's an alkane. And an alkane, it's saturated. Because it contains single bond between the carbon atom. Let's look at this. C5H10. So if we're using CnH2n plus 2, C5, we put 5 here. 5 times 2 is how much? It's 10. 10 plus 2 is 12. Obviously, this will be an alkene here. Because it's CnH2n. When we put 5 here, 5 times 2 is 10. It's an alkene. So it's unsaturated. So it's an alcohol. This one, let's check it. CnH2n plus 2 with 6 times 2, it's 12 plus 2, 12. I think this should be an alkyne. Let's check it. C6H, 6 times 2 is 12. 12 when you subtract, so it's an alkyne, this one. So which one? It's saturated, obviously, for this one to be butane. Because this one is CnH2n plus 1 with the OH. Let's confirm. 5 times 2, it's 5 times 2, it's 10. 10 plus 1. So it's not an alcohol, this one. Because with 5 carbons, we're supposed to say C5. And 5 times 2, it's 10 plus 1, it should be 11 with the OH. So this is not an alcohol. Okay, I apologize, guys. So the answer is A. No. Okay, no. Now I see. This is not an alcohol. It's either an aldehyde or a ketone, because remember it's now aligned to the formula of CnH2n with an O. Because look, if we put 5 here, this will be C5H. 5 times 2 should be 10. You see that with this oxygen, if we add here, it should be 10. So it's either an aldehyde or a ketone. So, but the answer is 2 points. It's A. Okay. Then let's move on. Let's move on to 2.17. I'm just having connection issues, man. I think there's network problem this side. Okay, I'm still waiting for this to open. Okay, 2.17. What's going on? Okay, it's responding. Okay. Okay, 2.17, we're at 2%. So now you have to move on to 2.18. Okay, 2.17, there is 2.18. Okay, fine. Let's look at 2.18. It says consider the two organic compounds represented by 1 and 2. Let's first identify to which homologous series they belong to. This one, because of the carbonyl group attached to carbon, so this one is a ketone. Carbonyl group attached to hydrogen on one side, and also this one is an aldehyde. And this will be methanol. And this one will just be 1, 2, 3. This will be propane 2-ol. Propane 2-ol. Or 2-propanol. Okay. Now, here it says which of the following correctly represent the homologous to which this was just straightforward. It's a ketone and aldehyde. So it's this one. The first one is a ketone, the second one is an aldehyde. It's not an alcohol. It's an aldehyde. Okay. So the answer is C. So it's very important to note the functional group of organic compounds. Now let's look at this one. 2.19. The structural formula of organic compound is represented below. First of all, let's identify to which homologous series this belongs to. It belongs to an alkyne with the general formula of CnH. 12 minus 2. Right, before it says IUPAC name. Let's first do the naming. Remember, ladies and gentlemen, here we have a functional group. So first of all, we have to choose the longest chain. The chain with the highest number of carbons. It can be straight or a branch, there's no problem. So we're going to say 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So the one with the highest number of carbons is 7. Can confirm 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, right. Now, after 7, let's identify any branch. This is a methyl. And this is also a methyl. Between the branches and functional group, which one do we give priority? Functional group. So it means in terms of numbering, we need to number the carbon atom starting from the nearest. So it's going to be 1, 2, 3, 4, 5, 6, 7. Starting from the nearest functional group. So you see that our functional group is between 2 and 3. So we take the smallest number, which is 2. Then we need to consider the order. So it means the name of this compound will be, we first look at the branches that one is at carbon number 5 and one is at number 6. So it means this would be 5.6 dimethyl. And what is the parent chain? The parent chain is 7 carbon. 7 carbon, we know it's hept. But now we have to mention where it's our double bonds. It's at, so it will be hept to ion. Hept to ion. So this is wrong. 2.3 is also wrong. 5.6 dimethyl hept. Yes, this is the correct answer, is B. Here it means they've taken the highest number, which is wrong. So we take the smallest number between the double bond and the triple bond. So the answer is B. It's 5.6 dimethyl hept to ion. Because 7 is hept, 8 is oct. All the time, with the functional group and branch, we give priority branch. I'm saying functional group followed by branches. I believe you guys are following. Practice makes perfect. So the answer here is B. Okay. Now let's move on. 2.20. Even this one we need to name, but now this is it's a halogen. Consider the condensed structural formula of organic compound is but this is not a condensed. It's not a condensed because the bonds that have been shown there. It's not a condensed, it's the structural formula. So it's not a condensed. Okay, fine. Right, let's now choose choose the longest chain. Obvious. Our functional group here is single bonds with the branches. These are our, it means we have to name them single bonds and the halogens. Okay, fine. So now we're going to say 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So it means the longest chain here is this one. Okay, here our functional group are halogens. So here our functional group is halogens. So it means here we consider the halogens as our functional group. So now where are we going to number? Look at this. If we say 1, 2, 3, 4. Let me repeat. We choose the longest chain. We identify any functional group and a branch, and we number the carbon atom starting from the nearest functional group or branch. Now we only have, these are also branches and also our functional groups. So this is bromo, and this is bromo. Now let us look at the position. This one is at position 1, 2, 3, 4. It is at position number 4. This one, 1, 2, 3. It's at position number 3. So obviously, we need to number the carbon atoms starting from the nearest branch here. So we cannot consider the one at position 4. We need to consider the one at position number 3 because where we can get to the nearest branch, where we can get the branch at the nearest. So it means we cannot move from left to right. So we have to move from right to left because here it's 1, 2. Okay, let me just use a different color. So we have 1, 2, 3, 4, 5, 6, 7, 8. But if they were both at the same position, then it means we can start from any because here alphabetically they are both bromo. Unless if we had chlorine and bromine, then we're going to consider the order. Which one comes first alphabetical? So this is gonna be 1, 2, 3, 1, 2, 3, 4. So this will be 3.5. Why 3.5? One branch is at carbon number 3 and the other one is at carbon number 5. So it's 3.5 dibromo. What is our parent carbon? Parent carbon, it's 8 carbon, which is just octane. Because oct means 8. Octane. Why ane? Because halo-alkane suffix NME must end with ane. So what is the answer here? The answer is C. 3.5 dibromo octane. 3.5 dibromo octane. I believe you guys are following. 3.2 dibromo octane. Suppose we do not have this. Let's assume we do not have this carbon here. I just want to illustrate something. Let's say we do not have this. This is not there. This one. Let's assume it's not here. It's not here. It's not there. Maybe at this carbon. Okay. Let me just try to raise the positions. Okay, let's just assume we do not have it. Like we have chlorine here. Just an example. Let's assume here we have chlorine here. Obvious, when we choose the longest chain, this will be our longest chain. But now, when we number the carbon atoms, when we move from left to right, the branch is at carbon number 3. And from right to left is still at carbon number 3. So the question is that now, look at this. Since they're both at the same position from left to right, what do we have to consider here? Obviously, we have to consider the alphabetical order. Which one comes first alphabetically between bromo and chlorine? Remember, it's A, B, C. So you see that bromo comes first than chlorine, right? So which means that we're still going to move from right to left. We give priority bromine than chlorine. I believe you are following. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it means now the name will be 3 bromo. And what is our chlorine? 6 chloro. Alphabetical, even if any name, we need to write alphabetical. What? Octane. Bromo comes over first alphabetically than chloro. So even when we are naming, we need to give, if they're at the same end, then we consider the alphabetical order. I believe you are following. This was just an example where I just added chlorine without the bromine. Okay, the answer is C. Let's move on. 2.21. 2.21, it says, which one of the following compound belongs to the same homologous series as butane? Same homologous series as butane, ladies and gentlemen, butane. Butane, same homologous series as butane. Remember, butane, it's an alkyne. And if it's an alkyne, what is its general formula? CnH2n-2. Let's do this. Let's count the number of carbons, which is I at number 8. In terms of carbon, 1, 2, 3, we only have 3 carbons. What is the hydrogen? 3, 4. We only have 4. Let's look at B. What is the molecular formula for B? 1, 2, 3. 3. How many hydrogen? 4, 5. It's 5. Let's look at C. C. How many carbons? 1, 2, 3, 4. 4 carbons. Hydrogen, 3, 4, 5, 6, 7, 8. 6, 7, 8. It's 8. D. How many carbon? 1, 2, 3, 4. C4. H. 6, 7, 8, 9, 10. This is 10. You see, this already is an alkane, this one. So it's out. C4H8, this is an alkene. Because the hydrogen has doubled as compared to the carbon, because it's CnH2n. So if you put 4 times 2, so it's already out. What's the C? 1, 2, 3, 4. It's out. Let's look at this one. If we plug 3 in the formula in general formula for an alkyne, so this was supposed to say C3H. 3 times 2 is 6. 6 when you subtract 2 should be 4. You see that the correct answer is A. Not this. Because this one it means it was 3 times 2, which is 6, minus 1, it's 5. So it's out already. So the answer here is A. We want the one which is the same homologous series, means same molecular, like same general formula actually. As butane. Okay? Right, then 2.22, which of one of the following is an isomer of this? It's an isomer of this. First of all, you must understand what is this. This is a carboxylic acid. Why am I saying it's a carboxylic acid? I spoke about the functional group of a carboxyl to say a carboxylic acid has the carbonyl bonded to hydroxyl group. So once you have carbonyl, bonded to hydroxyl group. This is the same as COOH. So already we have the COOH there. And if we write this molecular formula, it will be C. How many hydrogen? 1, 2, 3. 3 hydrogen. I'm saying carbon. Hydrogen should be 6 with 2 oxygen. So what does this mean? It means this is a carboxylic acid. And if we want to know the isomer of carboxylic acid, what is an isomer of carboxylic acid? What does I say? Carboxylic acid and then esters. These are functional isomers. So obvious, if we have a carboxylic acid and which want to have an isomer, it must be an ester. And obvious, it cannot be this. Besides, look at the molecular formula of this. It's C3H6O2. Let's look at the molecular formula of compound A. How many carbon are there? 3. Hydrogen, 1, 2, 3, 4, 5, 6. 6 with only 1 oxygen. Here we want with 2. So it's out. Let's come to this. This one is a ketone with how many carbon? 1, 2, 3. Hydrogen, 1, 2, 3, 4, 5, 6 with 1 O. You see, these are functional isomer, but it's not what we want. This out already. Let's come to this. This one, how many carbons are here? It is a carboxylic acid. So with how many carbon? 1, 2. It's only 2 carbons here. And how many hydrogen? 1, 2, 3, 4 with 4 hydrogen and 2 oxygen. You see, it's a different one because they do not have the same molecular formula. It's out. So the correct answer is D. So it has to be an ester. And besides, you see, this is an ester because carbon is attached to oxygen with carbon. And let's count the number of carbons. 1, 2, 3. That 3. Hydrogen is 1, 2, 3, 4, 5, 6. It's 6 with how many oxygen? 2 atoms of oxygen. So you see that they have the same molecular formula, but different structural, different functional isomer. So these are actually isomers. So the answer is D. I believe you are following, guys. Remember, practice makes perfect. By knowing the functional group and also the general formula of homologous series, the AGE, then you will never go wrong. Okay, let's now move on to the next one. I think this is the last one for this activity. Okay, then we'll say, okay, right. It says, when this group, this one, is present in a compound, the compound may be obvious. Maybe this, if it's like this, with an O, if you put a hydrogen, it will be a carboxylic acid. But do you have a carboxylic acid here? No, we do not have carboxylic acid. It wouldn't be propanol, it's an aldehyde, and with an aldehyde, it's just carbonyl with the H. So it's not, it's out. Even ketone is out. Even proper alcohol, it's out because with an alcohol, it's a carbon with OH. So obvious, it should be an ester. Methyl ethanoate. Methyl, it's an alcohol, it's methanol with ethanoic acid, which gives us the ester, which is methyl ethanoate. So the answer is D. This could be an ester. It could be an ester, not aldehyde, not propanol, not alcohol, I'm going to say. So this could be an ester or carboxylic acid. But since a carboxylic acid is not mentioned here, so the answer is D. Remember, practice makes perfect. Okay, so we also have another activity. I'll just go through activity 2. Then the activity 3 will be yours. You can go through that. So this is just straightforward. because it says letter A to H in the table below represent 8 organic compound. So first of all, you need to identify the homologous series to which they belong to. This one? Number A. There is carbonyl, but it's bonded to OH. Obviously, this carboxylic acid. And what is this? Its general formula? CnH2nO2. This one, it's an alkene. Then this one, carbonyl. So this is a ketone. Why? Because remember I said this is the same as this one. So it's here. And between this, there is carbon attached on both sides. So it's a ketone. And what's the general formula? CnH2nO. This one, what could be this? If you look at this might be an alcohol, because if it was an aldehyde, or this was supposed to be double, supposed to be 4, yeah. So if you let's write the formula for an alcohol. Let me say the general formula. See that we write this, or we write the CnH2n plus 1 with the H, with the OH. Where there is N, let's put 2. So this will be C2H. 2 times 2 is how much? 4 plus 2, it becomes 6 with 1 O. You see, this one is an alcohol. Even if we use this one, where there is N, we put 2, it will be C2H. 2 times 2 is 4 plus, which is 5 OH. You see that the hydrogen can be added to become 6. Then C2H4, what is this? The N is doubled. So this is an alkene, CnH2n. 3-methylpropane-2-O, this is a ketone, where the carbonyl is at carbon number 2. Then this one, with chlorine, it's a halo-alkane. Then 3-methylbutanol, it's an aldehyde. And what's the general formula of an aldehyde? CnH2nO. So by analyzing this, you can be able to answer the questions on your own. So it says, define the term unsaturated. You can do that. Write down the letters that represent unsaturated compound. Unsaturated compound. It means the one that is B. The answer is B. Letter that represent a chain isomer of compound C. Compound C, it's a ketone. And with the chain isomer, what does it mean? It means they have the same molecular formula but different chain length. Let's look at the one which is a ketone. Chain isomer. Look at this. This one, how many carbon are here? 1, 2, 3, 4, 5. So it's 5 carbon. How many hydrogen? 3, 4, 5, 6, 7, 8, 9. Or it's 6, 7, 8, 9, 10. It's 10 with 1 O. Let's come to this one. But it's 4 carbon. Meth, it's 1. So if we add 4 plus 1, this becomes 5. But since it's a butanol, oh, by the way, no, chain isomer, not functional isomer. Okay, I apologize. Let's look at the one. Remember, if it's a chain isomer, they must have the same molecular formula, same homologous series, actually. Right. Now, if you look at this, but2-on is also a ketone, but but it's 4, meth it's 1. This becomes C5. Obvious, this and this, it will be F. The answer is F. the chain isomer of compound. The IUPAC name of compound G, you have to name compound G. General formula of the homologous states to which compound E belong. Compound E belong, we want the general formula. Compound E belongs to an alkene because it's 2 times 2, which is 4. Alkene, what's the general formula of an alkene? CnH to N. What is a functional isomer? Define the term functional isomer. You can do that. Organic compound with the same molecular formula but different functional group. Okay, then compound A. For compound A, what is compound A? Compound A is a carboxylic acid. Write down the homologous series to which it belongs to it's a carboxylic acid. Draw the structural formula of a structural isomer. Structural isomer. Very important. Structural isomer of compound A. It means you want to draw structural, you are not drawing a structural formula of compound A. You are not drawing the structural formula of compound A. You're actually drawing the structural isomer of compound A. And what is the structural isomer of compound A? Obvious, since A it's a carboxylic acid, what will be its structural isomer? Obvious. I apologize. What will be the functional isomer? Obvious, carboxylic acid, its functional isomer, it's an ester. So it means you have to draw an ester of this compound. I will actually leave you to go through these questions on your own. Just pause the video and try to answer the question on your own. Okay, I actually wanted to address the question 9, this one. Let's go through this. The first one, it says, consider the organic compound represented by letter A, B, and C. A to C, okay. Let's first look at A. A has single bonds between carbon atoms, but there's chlorine here. There's chlorine here. It means this is a halo-alkane. And what is the general formula of halo-alkane? CnH2n plus 1 with an X. And this one, there's OH attached to carbon. This is an alcohol. And this is a primary alcohol. Carbonyl is attached between 2 carbons, so this is a ketone. Formula for general formula is CnH2n. Or this one, CnH2n plus 1 with the OH. Or CnH2n plus 2 with the O. Okay? The first question says, write down the name of the homologous series to which compound C belongs. C is a ketone. It belongs to a ketone. The IUPAC name of compound A. We want to give the name of compound A. Halo-alkane. Let's do the naming. What do you do? Choose the longest chain. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6. So the longest chain will be this one. Okay, after choosing the longest chain, we have to identify any branch. We have a branch here. This is methyl. Here we have what? Chloro. And here we have chloro. And according to what we said halogens do not take preference over alkyl group. Halogens do not take preference over alkyl group. Now, but when we look at this, we have chlorine here and we have chlorine there. But if we number the carbon atoms starting from the nearest, it will favor this side. 1, 2, 3, because we're getting at carbon number 3. This side is 1, 2, 3. Chlorine is at number 4. So it's 3, 4, 5, 6, 7, 8. Which means even though we mustn't give halogens priority over alkyl. The alkyl group it's actually at the middle. So it means there's no problem with this. So here we have to consider where we can number the carbon atoms starting from the nearest branch or functional group. So here we have to number from left to right, because if we move from this, we'll get our chlorine at carbon number 4. 1, 2, 3, 4. So it means it will be 1, 2, 3, 4, 5, 6, 7, 8. But we have branches, we have chloro and we have methyl. So it means alphabetically what we're going to say, which one comes first between chloro and methyl? C comes first than M. So it means the name will be 3. The first chlorine is at carbon number 3. The second one is at carbon number 5. So it will be 3.5 dichloro. Then 4-methyl. What is the parent chain? Parent chain is 8 carbons, and it's an halo-alkane, means it must end with an A. So octane. So it's 3.5 dichloro 4-methyl octane. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, this is the answer. So we have the answer. Then now, secondly, it says write down the structural formula. Write down the what? The structural formula of a tertiary alcohol. Write down the structural formula of a tertiary alcohol that is a structural isomer of compound B, which is true. Obviously, if you want a tertiary alcohol, it means the carbon bonded to what? The carbon attached to the, how many carbon are here? 1, 2, 3. The carbon attached to the OH or the hydroxyl group must be bonded to 3 carbons if it's a tertiary. So it means in terms of the structural formula, we're going to have this, but must have the same molecular formula, but different structural formula. Let's read the question again. The structural formula of organism, it means if it's a structural formula, we must also extend this OH because they want it as a structural formula. But usually in the exam, they cannot penalize you, but let's just do it for, so this will be the O with the H, the O with the H, because they want it as a structural formula. So let's count the number of hydrogen carbon. Okay, obviously it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's check this one. Is it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So this is the structural formula of tertiary alcohol that is a structural isomer of compound B. Why are we saying it's a tertiary alcohol? The carbon attached to hydroxyl is bonded to 3 carbon atoms. So that's why it becomes a tertiary alcohol. I believe you guys are following. Remember, practice makes perfect. Okay, we continue now. Here it says an alcohol and methanoic acid. An alcohol and methanoic acid are heated in the presence of a concentrated sulfuric acid to form an ester. That is esterification, actually. So now here it means they're saying, as I said, if we take an alcohol, we combine it with a carboxylic acid through a catalyst called sulfuric acid. then it will form an ester plus water. But here they said that the carboxylic acid that they've used here, it's what? It's methanoic acid. It's methanoic acid. So it's methanoic acid. Okay. Right. Then now they're saying in the presence of a concentrated sulfuric acid. So the question says, what is the role of the concentrated sulfuric acid? Here it acts as a catalyst. Or one can say it acts as a dehydrating agent. Okay. Now, the second one says, write down the name or the formula of the inorganic product that will be formed. The name or the formula of the inorganic. Remember, an ester, it's an organic compound. An ester, it's an organic compound. This is an organic one. So what will be an inorganic? Remember I said, when you take an alcohol combined with the carboxylic acid in the process of esterification, it forms ester plus water. So the water is an inorganic. So it's going to say water, H2O, or we say water because they say a name or a formula. I believe you guys are following. Now, here is the question statement. It says an ester, which they spoke about, contains 6.62% of hydrogen, 40% of carbon, and 53.33 of oxygen. The molar mass of this ester is 60 grams per mole. Use the formula to determine the empirical formula. It's what I was just saying. Now, to determine the empirical formula, first of all, you have to do this. We have to say, okay, fine. We start with the carbon, we have hydrogen, and we have oxygen. So I'm going to draw a table. So since you are given percentage composition, we take those percentage composition as the mass of each element. Because we assume that it's just a mass out of 100 gram. So first of all, we're going to say, okay, right. We want to write down the mass of the compound. Then after the mass, we have to calculate the molar mass. After the molar mass, we look at the ratio. I'm saying the number of mole, I apologize. Then we look at the ratio. Now, firstly, what is the percentage of carbon in terms of mass? Carbon has a mass of 40. So I'm just going to write 40. Hydrogen has a mass out of 100, it's 6.67. I believe this add up to. Oxygen, it's 53.33. Okay? Then we take my calculator. Oh, there it is. All right, we are going to calculate the number of moles of each element. Let me check. Hydrogen is 6.67, carbon is 40. These are adding up to, yes, 50. Okay, guys, I apologize. Connection issues. Let's continue, guys. Okay, so we have carbon, as I said. Let me use. So it's carbon, it's hydrogen, it's oxygen. We had the mass. What is the mass? Okay, this becomes 40 grams, 6.67 and 53.33. Now let's calculate the number of mole. Okay, let me just. So we have the mass, So this is the mass I was supposed to use. Okay, find 40. Okay, the mass it's 40, 6.67 and 53.33. Let's calculate the number of mole. Number of mole is mass over the molar mass. What is the mass? The mass we know it's 40 for carbon. So it means the number of mole will be 40 divided. Carbon is 12, right? Divided by 12 as the molar mass. Hydrogen number of mole it's mass is 6.67. Molar mass is 1. So this will give us 6.67. This one number of mole it's mass is 53.33. Molar mass of oxygen from the periodic table is 16. I believe you guys are following. So 40 divided by 12. 40 divided by 12. This will give us the molar mass of number of mole of 3.33. 6.67 divided by 1 will give us 6.6. So 53.33 divided by 16 for oxygen. This will be 3.33. Now we're going to get a ratio. To get a ratio, it means we're going to divide by the smallest number of mole. Yeah. Which one is the smallest? Obviously, we're going to have 3.33 is the smallest, 3.33. Divide by 3.33. To the nearest, it's 1. 6.67 divided by 3.33 divided by 3.33. We divide by the smallest number. 6.67 divided by 3.33. This will give us, to the nearest will give us 2. This will give us 1. This will give us 1. So it means the empirical formula of this is C1H2O1. So this is the empirical formula of this ester. Now we want to know the molecular formula. And to do that, we are given the molecular mass of the ester. So first of all, to do this, we have to calculate the molar mass of the empirical formula CH2. Okay, guys, I want us to continue with, already we have calculated the empirical formula for this ester. We got C1H2O1, which is just CH2O. Now, the second question says, use the calculation to determine its molecular formula. Right, to determine the molecular formula of this ester, we need to calculate the molar mass of the empirical formula, CH2O. Then to do that, we are going to add the number of, like, one atom of carbon has a molecular mass of, atomic mass of 12, plus 2 times the atomic mass of hydrogen, which is 1, plus atomic mass of oxygen, which is 16. So when we add this will be 30 grams per mole. So which means that we're going to say this is the molar mass of the empirical formula. And we are already given the molar mass of the molecular of the ester on its own. So we are going to get a ratio, and this ratio would be, we take the molar mass of the ester, which is 60, and we divide by the molar mass of the empirical, which is 30. And this will give us a factor of 2. So which means that when we want to determine the molecular formula of the ester, to determine the molecular formula of the ester, we're going to multiply the atoms, the number, like we're going to multiply the atoms of carbon, hydrogen, and oxygen on the empirical formula by 2. So which means this one will give us C2H4 and O2. And C2H4, this is the molecular formula of the ester. So we're given the molecular formula of the ester. It's C2H4O2. I believe you understand how we got this. And now the question says, the next one says, write down the structural formula of methanoic acid. Remember, we are told that an alcohol and methanoic acid was heated in the presence of concentrated to give the ester. Already we know the ester, it's C2H4O2. Now, what is the molecular structural formula of methanoic? Methanoic, our carboxylic acid, remember carboxylic is carbonyl with OH. So if you want methanoic acid, then we just attach the hydrogen. Why? Because the methanoic acid must have general formula. Remember, general formula of carboxylic acid, it's CnO2, like CnH2 and O2. So which means if we want methanoic, meth must have one carbon. So if we substitute by, where there is N, we substitute by 1, this will be C1H2O2. So you see that already we have 1 carbon and 2 hydrogen atom and 2 oxygen. So this is the structural formula of methanoic acid. Then now the next one says, write down the IUPAC name of this ester. And before we write down the IUPAC name of the ester, remember it shows that from this ester of C2H4O2, one side of the ester it's methanoic acid, which means the other alcohol will be methanol. Why methanol? Oh, methanol, I mean to say. It means they've taken methanol, they combine it with the ethanoic acid, then it will give us this ester because it has 2 carbon atoms. So which means that to draw the structure of the ester, we know that in ester it's separating an alcohol and the carboxylic acid with the oxygen. So we're going to say this part will be the weight and the other part will be the carbon. So we're going to say this is methyl. Oh, actually the name, okay, we're going to have methyl. Actually, we already have the answer because now it says it wants the name of the IUPAC name of this ester. Ladies and gentlemen, from the ester, we know that this ester has how many carbon atoms on it? It has 2 carbon atoms, which means from these 2, the methanol, since it has 1 carbon, so it means the other part is for the methanol. So it means if we take methanol with methanoic acid, so it will give us methyl methanoate, which will be